Okay, so first off, let's draw a parallelogram. So it looks kind of like a rectangle pushed over on its side. So opposite sides are parallel. The notation we use for parallel on a picture is we put little arrows. So that side is parallel to that side. And then we put, so that's one arrow, one arrow. This side we put two arrows. So this is parallel to this. Just to differentiate that. So one arrow is parallel to one arrow, two arrows parallel to two arrows. If we had like 17 sides, that would be, we'd have to be able to have all these different symbols that represent which sides are parallel to which. Okay. Okay, the naming convention. The way we name parallelograms is using the corners. And so the corners will actually usually have a letter that represents each one. So I'm going to call this parallelogram, label it A, B, C, D, and the order of the letters does matter. The location does matter. Yes, what's up? Because I'm going to put on YouTube, so that way if anybody's absent, they can watch the lesson. Okay. So that's a great question. So I'll show you guys all that stuff. Don't worry. I've got a channel and everything. It'll be okay. All right. So the four corners. Now notice we use capital letters. Why would we use capital letters?
Does it matter?
Why would we use capital letters? Well, think about what these corners are. What are these corners? There's vertices, but what's a vertex? What is that? It's a point. And what notation do we use to represent points? Capital letters. Okay, so we label points with capital letters. These are just points. Okay, so we have 4 points connected right here. So the way we name a parallelogram is we just draw a little parallelogram, and we name it by the vertices, and the order here matters. Okay, so the way we name it is we start in the top left, and we go around the figure clockwise. So A, B, C, D. That's why whenever you first look at this, you may think that I put the letters out of order, but in fact I have. There is rhyme to my reason to my rhyme, something like that. I don't know. Okay. So then, what are the vertices of this parallelogram? Well, they're the 4 corners: A, B, C, and D. Opposite sides are just what they sound like. They're opposite. So AD and what's opposite from AD? Oh. Okay. And then we have another pair of opposite sides, top and bottom. So AB and DC. Okay. Opposite angles, same idea. They're opposite. So angle A and angle C are opposite angles. And angle B and angle D are opposite angles. And then finally, we have this potentially new word, consecutive. So consecutive angles are angles that are basically right next to each other. Okay, so as you go around the figure, if you have 2 angles, one after another, like we have A and then B, those are called consecutive angles. They're right after each other. So one pair of consecutive angles would be angle A and angle B. Okay. Another pair would be angle B and angle C.
Consecutive means what?
One right after the other. Like if you're absent for 4 consecutive days, that means 4 in a row. So here, if you go around the figure and have an angle next to an angle, they're consecutive. So A and B are consecutive, but A and C wouldn't be consecutive because they're not one after the other. Okay, so B and C are consecutive. What's another pair of consecutive angles? C and D. And then what's the last pair of consecutive angles here? D and A. Or angle A. So that's just a way that we can refer to these angles when we mean they're next to each other. We call them consecutive. And then finally, the diagonals of a parallelogram. So let's draw another little parallelogram down here. The diagonals are line segments connecting opposite vertices. So if I have A, B, C, D, diagonals connect D to B and A to C. And so our diagonals here would be segment AC and segment BD. Okay. So there's 4 theorems, or basically you can think of as properties of parallelograms. Well, there's really 5 properties. The first one, we've already talked about, the definition. Opposite sides are parallel. Okay. The next theorem is opposite sides of parallelogram are congruent. So if we draw another parallelogram here, then the top is congruent to the bottom, so just put one little tick mark. And the right side is congruent to the left side, so I'm going to put 2. Because notice the left and right aren't necessarily the same as the top and bottom, right? They're just the same as each other, so that's why we have different numbers of tick marks. Okay. The next one says consecutive angle pairs of a parallelogram are supplementary. What does that mean? They add up to 180, right? So sum of 180 degrees. And so if we draw a parallelogram, 180 degrees. So if we draw a parallelogram, I'll just call this angle A, B, C, and D. And angle A and angle B aren't congruent. They're not the same. Instead, together, they add up to 180. So the measure of angle A plus the measure of angle B is 180. Okay. Now, angle B and angle C are also consecutive angles. Okay, so angle B and angle C together also add up to 180. Measure of, so the degree measure of. Okay, so all we're saying here is the measure of angle A plus the measure of angle B is 180. The measure of angle B plus the measure of angle C is 180. Are these the only 2 consecutive angle pairs? No, there's actually 4. We already wrote them up there, right? But the general idea is if they're consecutive angles, then they add up to 180. So I'm just going to put etc. here. So this works for all 4. I'm not going to write out all. Okay. So far we've got opposite sides are parallel. Opposite sides are congruent. Consecutive angle pairs are supplementary. And actually, opposite angles are congruent. So if we draw a parallelogram, then this bottom left angle is opposite from this top right one, and they are congruent. This top left one is congruent with the bottom right one. Okay. Now notice again, top right isn't congruent to bottom right necessarily. Okay? These opposites are equal. And then finally, the diagonals of a parallelogram bisect each other. So let's draw another parallelogram. Hopefully by the end of this you are getting better at drawing parallelograms. I know I am. So we have a diagonal drawn from there to there, and from there to there. Think about what this word bisect means. What does bisect mean? Yeah, they cross, but specifically, they cut it in half. Think about a bicycle. Have you ever ridden a bicycle that has different size wheels?
Yeah.
And then it's not a bicycle, it's a different name. So a bicycle is something that has 2 wheels that are the same size. Okay? Bisect cuts a segment into 2 of the same size segments. So if this diagonal bisects, if this first one bisects the second one, then this must be congruent to this. But they bisect each other, which means the second one also bisects the first one, so this must be congruent to this. So we end up having 2 pairs of congruent segments. So this length right here is the same as this length. And let me move my paper here. This length is the same as this length. Okay, so from here to here is the same as from here to here. Okay. Let's do some examples really quick. Start off just with some identification. So example 1, AD is parallel to what other line segment? So AD is parallel to what? BC. Okay. AB is equal in length to what other line segment? AB, so top is the same as the bottom, so DC. Could I also write CD? Sure. Remember, in line segments, the order doesn't matter. So name the parallelogram. So we start off by writing parallelogram. We don't write out the word parallelogram because we'll all misspell it every single time. Instead, we draw a little parallelogram. And then we have A, B, C, D. Remember, we start in the top left and then just go clockwise around the figure. So A, B, C, D. And this is the general naming for any polygon, really. Anytime you're naming a polygon, you usually start at the top left and just go around it. So if it had 27 sides, you would call it a 27-gon, and then you'd name all the letters going around. Name the vertices. What are the vertices of parallelogram ABC? Just A, B, C, and D. Remember, vertices, that's plural of vertex, which is just the corners. It's like a triangle. Okay, what angle is opposite from angle C? Angle A, opposites. And it says name the diagonal having a positive slope. Now think about what that means. Positive slope.
Oh, no.
So going up, but I could draw a line like this, and that's going up. Is that a positive slope?
No.
No. So how do we? What's the direction have to be? From left to right, it has to be going uphill. So which diagonal on our parallelogram is going to have a positive slope? So D. And notice it's not drawn. You kind of have to imagine it. D to B would have a positive slope. Number 7 is still with the same picture. 7 and 8 are both the same picture. It says two angles that are supplementary to angle C. So what theorem do we have that has to do with supplementary? Which one? Good. So when we see supplementary, or when we think 180, consecutive angles, right? So consecutive. So let's look at our picture. What angles are consecutive with angle C? Well, D, if we go this way, and then what's the other one? B. Now notice, what do we know about D and B, by the way? What's the other theorem say? Opposite angles are congruent. So if these are the same, right? Well, of course they're both supplementary to the same angle. Okay? So angle D and angle B. And then finally, segment AC bisects what other segment? Now again, is AC already drawn? No. What is AC called? What do we call AC? That's one of the vocabulary. What is it? A diagonal. So the AC is not already drawn. It's the diagonal. So, what segment does AC bisect? The other diagonal. Right? The other diagonal, which is B. Okay. Now again, you may want to make a note right here. This is a diagonal. And by the way, just, whenever I say you may want to, I mean do it. Did I spell diagonal right? Okay. Diagonal. There we go. Should have an O in there. Diagonal. Oh, didn't look right. There we go. All right. Example 9 says draw. How do we read this? Okay. And so let's draw it. Now notice the 4 corners. We start in the top left with the first vertex, and we go around the parallelogram. And it does matter. So you want to make sure it's not meant to be complex. It's meant to be the most straightforward way. Otherwise, you'd have people doing zigzags and all kinds of stuff. So this way, it's just go clockwise. So G, H, J, K. Now it says the measure of angle K is X. So let's label this angle right here. Let's call it X degrees. And the measure of angle J is 2x minus 2. So let's call this, let's put 2 marks there. And this is 2x minus 2. Now, what's the relationship between K and J, between those two angles? Okay, so they're consecutive angles. Let's write that down. Consecutive angles. And we know consecutive angles are, their sum is 180. What's the other word for that? They're supplementary. And so we know that the measure of angle K plus the measure of angle J is 180. Now we're told the measure of angle K is X degrees. We don't have an exact number. We know it's some unknown. And we know that the measure of angle J is twice that angle minus 2. Okay, so like if X were like 40, Right? Think about it this way. If x were 40, then this one would be twice 40, which is 80 minus 2. So this would be 78. So 40 and 78, though, don't add up to 180. So x can't be 40. Okay? Now you could continue that trial and error process all day long, and you might eventually come up with the answer. But that's why algebra was created, to shortcut that. So we say, well, how many x's do we have here? We have 3 x's. So we have 3x minus 2 equals 180. So since we have a minus 2 right here, remember we do the opposite. We add 2 to both sides. And so we get, over here, 3x equals 182. And how do we solve for x? Okay. And so we get x equals 182 divided by 3. If we want an answer, we would actually we'd probably use a calculator, and we get 60.6666. 60 and 2/3. All right. Next, our last 4 examples. It says use the drawing for the examples. It says a measure of angle BAD is 65 degrees and DB is 12. Okay, so BAD. So I'm going to outline that. So BAD is 65 degrees. Now, can we find angle 7 using that? Well, we're looking for this angle right here. Do we know any other part of BAD? And we know the 30. So using the angle addition postulate, we say, well, that means these 2 smaller ones have to add up to the bigger. All right? So the measure of angle 7 plus 30 is equal to the measure of angle BAD. All right, so in other words, we put these 2 small angles together, we get the big angle. Everybody okay with that? So we're looking at the big angle here is BAD. That's we're told is 65. So we can say the measure of angle 7 plus 30 is equal to 65. And so to figure out the measure of angle 7, well, what number plus 30 is 65? Well, the shortcut to that is subtraction. We subtract 30. So we get the measure of, it's given right there. So we're using the given information. So the measure of angle 7 would be 35 degrees. Now think about that for a second. If 7 is 35, we have 35 plus 30, which is 65, which is what we were told it had to be, and so it works out. Okay. Now we're asked about angle 5, which is down here. Okay. Now remember, opposite angles of the parallelogram, which I'm going to do here in green. So this angle up here is going to be the same as this whole angle right here. Okay, but when we draw the diagonal, it doesn't necessarily mean anything about these parts, these bottom parts, okay? But these lines are parallel, right? Top and bottom are parallel. And the diagonal we would call a what? That's a name. What is that called when it crosses 2 lines? Say transversal. So if we have a transversal and parallel lines, we have some relationships. In particular, we have alternate interior angles. So these are alternate interior. And so angle 5, which is right here, is the exact same as this angle up here. So angle 5 is equal to 30. Do you think that would always be the case, that these angles will be congruent for a parallelogram? Well, let's think about it this way. Are these, for a parallelogram, will these lines always be parallel? For a parallelogram, sure, by definition, they'll be parallel. And so if we draw the diagonal, will that always be a transversal? And so we can say with 100% certainty that these will always be alternate interior, so these will always be congruent. Now, what other angles will also be congruent based on that? 7 and 6 must also be congruent. So I'm going to skip to number 12. Because we just found 7 to be what? 35, so 6 must be 35. I'm just going to put a note over here to myself, alternate interior angles. Okay, next it's asking for the measure of angle ADC. So ADC, so that's this big angle down here. So we're looking for this angle. Do we know any other angles that are related in any way to this angle? BAD, how is BAD related to ADC? Why are they supplementary? Because they are consecutive. So I'm going to write that word again, consecutive. That's the new vocabulary word for the day, basically, so expect to see it. So consecutive angles. And so the measure of angle ADC plus the measure of angle BAD must be 180. Now we know BAD because it was given to us. So that must be 65. So how do we solve this equation? Okay. What else? So we subtract 65 from both sides. We get the measure of angle ADC equals 115. And then finally it asks us to find EB. So look at the picture and you locate EB for yourself. Where is EB? How would you describe EB to someone? The segment. Okay, where's that segment located? Okay, inside the parallelogram. Okay. Can you use any other of our vocabulary words to describe EB? Okay, so what does that have to do with diagonal BD? It's part of it. How much of diagonal BD is EB? It's half. How do we know? Because that word bisect, right? So this diagonal AC bisects BD. So this must be congruent to this, which means EB must be half of BD. So let's write that down. EB is a half of DB. Do we know how long DB is? How long is DB? How do you know that? Crystal ball? Oh, it's given. All right, we look back up to our given information. Remember, you're not going to be given a problem where you don't have enough information. So, at least not in class for the most part. So, EB equals a half of 12. And what's half of 12? So EB must be 6 units long. All right, so what questions? Right here. What questions do we have? So far? All right, so we have about 25 minutes in class. There are 13 problems, 13 questions. You should have sufficient time right now to do these 13 problems. Now is the time to work. Now is the time to ask questions. Okay? So go ahead and get started. I will hand back tests here in just a few minutes.